What'd you think? You liked it? Do we have a vote for 27? Doing it together? Do we have a vote for it? We have one vote in the back. Any other votes? Anybody second 27?
25.
Okay, well, we can't do 27 because we haven't done logarithms yet. Some people have seen it before, so they might have been able to power through it, but it's okay. You don't have to do 27. I gave you, I mean, you could, if you looked ahead, you could do it. You could figure it out, but we're not. We'll go over it last if we have time. Other votes, what? 28? Oh, we can, let's do 28 and just see what you get to, okay? I'm curious about how far you guys got on 28, because you shouldn't really been able to finish 28 if you didn't look up how to do it. I'll do 27 and 28. I was very interested to see if you guys actually, what I like doing sometimes is giving you things you can't do, and seeing what you see. If you go ahead and do a little bit of research, you could have figured out what you needed to know in order to solve this. The thing is that it's also interesting to me what kind of math you guys make up. The back row is giving me an evil face here, or just really like, I don't like him anymore. Let's do 28 here. What's the first step? We're trying to find an inverse, right? What's our first step? Well, hold on. Let's just switch first. I like switching first. So x is equal to 1 plus e to the y over 1 minus e to the y. And now what? Yeah, so we have x times 1 minus e to the y equals 1 plus e to the y. Now what do we need to do? We need to distribute. Okay, so now you can go a little further. What else can you do?
Subtract e to the y.
Yeah, let's do this. Let's make it x is equal to, let's make it this actually. I like keeping as many things positive as I can. X minus 1 is equal to x e to the y plus e to the y. All I did was add x e to the y to both sides and subtract 1. It's the same thing. Are we okay so far? Why am I doing that? Yes, yes. Let's be a little more specific. I like math and I want to solve problems, but you want to isolate what?
Isolate the y to the y.
We want to isolate. Why do we want to isolate e to the y?
Because we need to add.
We want to isolate y, so we want to get all the y's onto one side. That's what I was getting at right there. So what do we do now? Factor out. Yeah. So you have x minus 1 is equal to e to the y times what?
X plus 1.
X plus 1. Now what can you do? Yeah, so now you have e to the y is equal to x minus 1 over, you needed to know nothing else. You had the ability to go this far. Even if you didn't know what e to the y meant, you could get this far. How many y's do you see up there now? 1. We've done most of the work here. You don't know what to do next because many of you have not studied. What do you need to know about next? You need to know about logarithms to do it. This is an exponential, that's an exponent, e to the y, anything to a power. It's going to be an exponential equation. Exponential equations are identical, a different way of writing logarithms. Logarithms allow you to solve exponential equations. Exponential equations allow you to solve. Those aren't their only uses, but they're totally related. So what's next in our topical list? We will learn to use logs and exponents. And it's actually a really short conversion. I'll show you what it looks like. Log base e to the x minus 1 over x plus 1 is equal to y. The inverse, and then log base e is something called natural logarithm. This is actually what it looks like. ln of x minus 1 over x plus 1. And if you want to write it a little differently, this is what you're going to see sometimes. Those would be the final answers. We're not going into that yet, but that's what it looks like right there. Okay, once again, okay, just said we're not getting into it. I'm just showing you what it visually looks like so you can have that exact question in a few days, okay? ln is a shorthand for log base e. E is the natural number. N is a natural number.
There's a log
ln.
and LN.
There's a log button on your calculator and there's an ln button on your calculator. They are different. They are different. Yes. Ln is log base e. Log by itself is what is the what the default base we count in is? We count in base 10. Log without a base is base. That's all we're getting into right now. But if you've gotten this far, that's 90% of the work right there. The next steps you don't know how to do because we haven't studied logarithms, but it's very quick. It's very quick. Okay, moving on. So this is it's actually shorter for this one. This would be e. We can do that. We're not going to do that one now. Okay, any other ones? Any other ones?
25.
Shh. We wanted 22. I think someone else asked for 22 as well, right? 22? Oh, this is the one you had time to do in class, right? We didn't really get to it? Okay. How many people like physics in this class? Let's see hands here. What do we think of physics? 5, is it the best thing in the world? 0, is it the worst thing in the world, like a black hole? Wow, there's a lot of different answers here. We love it and we don't like it. Okay, that's fine. In the theory of relativity, the mass of a particle with velocity v is m naught naught over the square root of 1 minus v squared divided by c squared, where m naught is the rest mass of the particle and c is the speed of light. What does it mean by rest mass? Anybody can you explain that to me? What does rest mass mean?
The mass of a...
Mass when it's not moving, because what happens when it starts moving? Yes, its mass changes, yes. Find the inverse function of f and explain its meaning. So what are the constants in this?
V... wait, no. M
No.
0,
It's called m naught. That is a constant. That stays the same. It is called m naught. What does naught mean? It's all for naught. What's it mean? Nothing. It means nothing. 0. It's another way to say 0. Naught. All for naught. naught. It's vocab word today. You learned ambivalent and not. All right. V squared, is that a constant?
No, that's a...
No, that's the function is written in terms of v squared. What is really a constant in here?
C.
Yeah, very constant. I know that's totally improper English, but we'll just say it's constant. It's why did I say very constant there?
It's speed of light.
It is the speed of light, but it's one of the universal constants that we measure many other things on. Do you know what we use the speed of light to measure?
Measure the distance between 2 points.
We use, okay, that's a more practical, but there's actually a more practical distance. It actually is used to strictly define a very common distance that we use in this country. What is it? What? What's the definition of a mile? 5,280 feet. It's okay, so to get a mile we need feet, right? That's the common definition of mile, but to define a foot, what do we need? Inches, then what? So we can keep on going down and smaller, right? But the point is that actually inches is defined as 1/12 of a foot. We need to define foot. Does anybody know how foot is defined? This is a really, and think about it. Can you give me, this is not tautology, but v is equal to m naught. That stays the same because it's a constant all over what? The square root of 1 minus over. And now what do we have to isolate? What are we isolating? Isolate what? M. Right. So what do we multiply by? We could take this right here. Or we multiply both sides by it. So what does it become?
I think you first isolate the root
Well, yes. Well, there's many things here. So we do that, and then we multiply by v, and it equals what? Good. What should I do now? I don't like square roots. Let's square it. So what do we end up with? 1 minus m squared over c squared times what? If we square both sides, what does the v become? Thank you. Equals what? M naught squared. Right. Now what do we have to do? Multiply. Yeah. Get rid of the parentheses. So we're going to distribute. So we end up with v squared minus v squared m squared over equals what? M naught squared. So what do we end up with? We end up with v squared minus m naught squared is equal to v squared m squared all over c squared. Good. What should I multiply both sides by? C squared times v squared minus m naught squared is equal to v squared m squared. Now what do I divide by? So m squared is equal to c squared v squared minus m naught squared all over what? What? Yep. So what does m equal? C squared times v squared minus m naught squared all over what? Now here's the bonus question, everybody. That would be correct right there. You are able to simplify that sum. Can someone tell me what the terrible thing you could do to simplify that? I mean, if everything under the square root sign is squared, what can you just do? Oh my gosh, no. What's the one operation inside the square root that messes up your dream of simplifying that nicely? The minus sign. If it was all being multiplied together, what could you do? You could do exactly what I just said. You can break this apart into two things. You can make it m is equal to the square root of c squared over v squared times what? Minus m naught squared. Remember square roots, everybody? Right? You don't see what I did there? Do you see what I did there? Right? Because if you multiply the two things underneath the radicals, you get the same thing that's right here. But why did I do that? Yeah, so what do you end up with? C over v times the square root of? Yes, that's why I did it.
Wait, is it positive or negative?
Ah, which where? Front here? That's a good question. I added in the square root sign. So, you wanna know right here, could this be positive or negative? What do you think?
It can be both positive.
It's gonna be positive. Why? What? Yeah, we're dealing with positive mass. There's no negative mass. No such thing, negative mass. No. Always remember. The v squared just on one side. What do you mean? Yeah, it's two things multiplied together. This is the same thing as c squared over v squared times v squared minus m naught squared. Right? There's the intermediary step. And then you have two things. The square root of a times b is equal to the square root of a times the square root of b. Got it? Good? Okay, does that help you right there? Find an explicit formula for the inverse, right?
Yeah.
And then you're supposed to have both. So what do you do first to find the inverse?
To switch the...
Excellent. Now what? What's our goal now?
And then
What's our goal?
isolate.
Isolate y. That's our goal. What are we going to do first? Square both sides. Ah. Dang it, this is really hard, isn't it? Oh, it's so tough. So tough. So what do your problem is you're trying to isolate what? What's the problem? There's y. How many y's do you see right there? Y's in two different places. Huh. So hold on a sec. Record. So we have our functions. So what do we have here? Let's just take a look. We have, so that right there is f of x, and this is y equals x. So could we draw our inverse? Just give a basic idea of what it looks like? Yeah, it's a reflection, right? So that right there is f inverse of x. Exactly. Good. So they ask you to find an explicit formula, I think, right? It's 2. So what does x equal here? Negative 2 plus or minus 2 root 1 plus x squared all over what? 2. 2 times, what can I factor out of the top? A 2. Negative 1 plus or minus the square root of 1 plus x squared all over what? What's on the bottom? 2. What cancels now? The 2's cancel. So what are you left with? X is equal to negative 1 plus or minus the square root of x squared. Now that's going to be our inverse function. Now that's a plus or a minus, correct? Something a little weird going on there. So we have to go back and look here. What was the domain of our original function? What? X is greater than 0. So that's the domain of our f, right? So that's going to be the range of this function. So what's the range here? Y such that what?
Y greater than 0.
Greater than 0, because the domain of the original function was x such that x is greater than 0. So this is plus or minus. Which one of that will lead to a always positive number? Okay, a square root, that's always going to be what? It's always going to be positive, right? So if we're subtracting from a negative, we want that number to be what in order to make the whole thing positive? We want it to be what? Say it again. Okay, if you have -1 minus a positive number, what's that going to be? Negative number, right? If you had -1 plus a positive number, it could be what? It could be positive. It could be positive. So what do we want that to be? We want it to be positive. So our guess for f inverse is going to be what? -1 what? Plus the square root of. So how can we test this? We can graph it. It becomes, so 1 plus x squared is always going to be positive, right? Do you agree? Now I have a question for this. Why doesn't this graph right here, why doesn't this graph, sorry, why doesn't this go below the x-axis? Why isn't it negative? What's the smallest that could be? 0, right? Do you agree that smallest that could be is 0? So what's the smallest 1 plus x squared could be?
1.
What's the smallest the square root of 1 can be? 1. What's -1 plus 1? 0. So what's the smallest this could be? 0. Could it ever be negative? No, because the smallest this can be is 1, and you're adding -1 to it, so the smallest the whole function can be is, that's why it goes to the origin.
Why x only is positive?
It's not. We're saying you can plug in anything you want, but the output is going to be what?
Oh, always.
Yeah, so just take a look here. Just wait here, because there's something else here. We didn't graph something here. Ready? Window. I'm going to change this to -4. That's our first function, right? Here's our second function, and here's our... So there's a problem there, isn't there? What's the problem?
It can be negative.
The function we wrote can be negative, but does that represent the inverse of the function as written? Does this part of the function right here reflect over? Do we want it to? No, we don't. There's a problem here. So it's an easy fix, everybody. Remember, what's the relationship between the domain and range of a function and its inverse? Exactly. So let's just take a look at this here. So right here, ready? Here in the let's use purple here. Here's our original function. That was, what was it? F of x is equal to what? The square root of what? The square root of x squared plus 2x. Yeah. Correct? And we found that the inverse, we're pretty sure was what? F inverse was the square root of what? -1 plus the square root of. Well, they told us on this one right here, they told us the domain here was x has to be. So therefore on this one, what does y have to be? Y has to be what? Greater than 0, correct? Well, on this one, when we graph this, we know that the domain is x greater than 0. What's the range on this thing? The purple. Where does the purple only exist? Greater than 0. So if that's the range up there, what's the domain up here? Greater than 0. So if we're going to accurately graph this, we go back here, and what should I add to the end of this bottom function?
X is greater than
Yeah, exactly. So remember where this is? I'll put this in. You have to make sure it goes out. See how it's outside the square root sign there? You put x, and what was it? Second math. X is what? Greater than 0, and we'll keep that side in just so you can see it. Look what happens here. We graph the... There is the original function. There's y equals x, and what's that represent right below it? Oh, excellent. So if you don't restrict the domain, is it a proper inverse? No. So in order to write the proper inverse sometimes, what do you have to be very careful about? The domain and the range. So if they give you the range of the function, you have the domain of the inverse. Piece it all together. Piece it all together. So we eliminated, by writing that function, we eliminated the other side. Hold on one sec.
32.
32? You don't like 32? 32?
Out of it.
That's nice. Ooh, this is a good one. I like this one.
The F over 1. The 1 over F.
What do we have here? X and Y. What are some easy points that look like are on the function?
1.
Looks like 1 is on the function, right? And also, let's do that one right there. So let's say 2. Let's just make things line up, shall we? We're estimating here. So what else is on there? 3, 3 looks like it's on there, the original function. What does it look like this one is right about here? 2 comma, let's say 1.5. And then maybe, it's estimating, yes, sometimes you gotta estimate, it's amazing. So 4, 4 is right about here. So it looks like 4 is at, let's just say 5. Let's just say that. Let's just use that right there. We're just estimating here. Are they asking for super... Are they asking for... This is the original function right here. 4 is up at 5 somewhere. Okay. So, we want the x value to stay the same, but what do we put here? What do we label right there? 1 over y. F of x, right? So what do we end up with? What's 1 over 1? What's 1 over 1.5? 2 over 3. And 1 over what? 5. So I'll change colors here. Let's go to silver. So what numbers stay the same? 1 stays the same. Correct? So then we got at 2, what is it? 2/3. And at 3, what is it? 1/3. And at 5, what is it? At 4, what is it? 1/5. So what does this thing look like? Is it ever going to get to the axis? Is it ever going to cross? No. Because this thing just keeps on getting bigger and bigger, right? 1 over that is going to keep on getting bigger and bigger. It's going to get smaller and smaller. 1 over a number, can that ever equal 0? 1 over a constant never equals. There's your graph right there. That's all they wanted.
Wait,
that's it.
What about the...
What about the what?
Extended it to the left direction.
It doesn't. This thing stops. It doesn't extend. So we could stop it right there. It would stop at here, wherever we think it stops. There's no arrows on it.
Y number 2 is 2 over 3.
Why is it 2 over 3? Because 1 over 1.5 is equal to 2 over 3. Got it?
You mean the original function, there's no any other input
that is it.
1, so then
yes.
The 1 over that you cannot
go left. Yeah, you keep the same domain here. There's nothing defined to the right or left of those values right there. Got it? Sound good?